Hi, this is our experiment into the structure and performance of the internet. Our group is me, Molly Brown. We also have Alex Penzick, Jasmine Tate. Our experiment and how we gathered the data was each group member was responsible for tracing the route from their computer to one website. We each had our own assigned website that we were tracing the route to. We each had to record the ping delay for each hop between our computer and the website. Um, we had to record the packet loss for each hop, and we had to perform the trials at the correct times during the day. And here we have some screenshots of what that looks like, tracing the route and then pinging the different hops. The hosts were pinged, or the hosts pinged were chosen in order to include a variety of locations so as to be able to measure how distance and location impacted the results. So I pinged University of California, Santa Cruz, due to it being on the West Coast. So it was a large distance from us since we were all located on the East Coast. Jasmine pinged Virginia Tech so that there would be results for a location on the East Coast. And Alex pinged Oxford University due to it being at an extreme distance all the way in Europe. So the trials took place on Wednesday, March 17th. This is because it was a weekday. And each group member recorded the ping delay at the 5 different time slots throughout the day in order to test like the effect of the different times on the data. So the analysis regarding the routers, so UC Santa Cruz had the most hops at 14 to get from the local server to the host server. And so this is potentially due to the fact that the data was traveling throughout the entire country and had to make many stops along its path to California. And then Oxford and Virginia Tech had roughly the same amount of hops. Virginia Tech or Oxford had 8 and Virginia Tech had 7. So Virginia Tech was somewhat close, which is possibly why it had a few stops, so few stops. And our theory for why Oxford had so few stops is that since we are on the East Coast and Oxford is also on the coast in Europe, the data was mostly traveling through the water or over the water, and so did not have to make that many stops.
Oxford's server path had 3 routers that had 100% packet loss across all 5 testing time periods, which is shown to the right in red. Virginia Tech also had a router that had 100% packet loss across all 5 time periods. We conducted several tests with different packet sizes to see if this would correct the packet loss, even taking the packet size down to 1 byte. However, all 4 routers still resulted in 100% packet loss. Our hypothesis for why this could have happened is maybe due to a high traffic volume going through those servers. Another possibility is that these servers could be private, not allowing them to be pinged. Not taking into account the 4 routers with the 100% packet loss, UC Santa Cruz had the highest instance of packet loss at 5%, although this only occurred during one time between 10 a.m. and 12 p.m. Multiple tests were conducted on this server to see if the packet loss would change, but the 5% packet loss continued to occur. Also, with the exception to the outliers, Oxford was the only host which had 100% packet loss amongst all of its routers. We think this possibly could be due to the time zone difference, therefore causing there to be lower traffic at those times since it was the middle of the night in Europe. Virginia Tech had fairly consistent packet loss among all 5 time periods, with usually only a difference of about 1%. and it also had the most routers that experienced packet loss.
So this is our ping delay data for the routers to Virginia Tech. We omitted the router with the 100% packet loss rate just because that would be way above the chart, make it very hard to read. You can see it all looks fairly normal, except for the one yellow line, which represents one router that was very variable on its ping delay. We'll talk about that in a little bit, but one of the most interesting things we also noticed here was that the routers seem to be split into two distinct groups. There's this upper group and this lower group at the bottom. This is our ping delay data for routers to the University of California, Santa Cruz. You'll notice, just like in the last one, the routers also seem to be split into two main groups, and they all seem to be fairly similar to each other besides that. This pink dotted line in the middle is representing the average time and shows a pretty steady trend. And then this is our ping delay data for routers to Oxford. You'll notice there's not much data on this graph, and that's because we, again, omitted all the routers with 100% packet loss rate. That would make the data very hard to read, so we just kept them out of this graph. So we only ended up having 5 different servers that we could really ping and get data from. Again, you'll see here that the routers are split into 2 distinct groups with that average time in pink in the middle. And this is a graph of the average ping delay data for all routers. As expected, University of California, Santa Cruz definitely has the highest ping delay on average amongst all of them. And like we discussed earlier, this is most likely due to the long distance that it had to go across for each of its hops. Oxford was a little bit surprising to us that it had the least average ping delay. This is most likely due to the fact that we again just didn't have very many server hops. Even though it seems far in our head, it's really just since we're both on the coast, not that far in server time. And then Virginia Tech was similar to Oxford, but just a little bit more. This green line is the average for all of them put together. So regarding the ping delay, one of the most interesting things we noted was that yellow line on the Virginia Tech slide with the router that fluctuated a lot. All of our servers fluctuated, none of them were completely steady, but this one fluctuated between 12 milliseconds and 57, which is a very large range, and we don't have many hypotheses why. Our only real thought is that it could maybe be due to the traffic intensity at each of those times, which were really skewing the results. But yeah, that one was pretty interesting. The average of the host servers, when we put them all together, we saw there was a peak delay time between 6 and 8 p.m. and there was a dip from 10 p.m. to 6 a.m. And this makes sense. And we figured it was potentially due to computer usage. Most people are on a little bit after work, and the fewest number of people are on their computers, and thus the fewest number of people are using traffic on these servers when it's very early in the morning. One thing to note, though, is although we did conduct trials between 10 p.m. and 6 a.m., none of the tests we conducted were from 11 p.m. to 6 a.m. So this could be a source of missing data. It could be a source of, just something we can improve upon if we were to do this again or to further our results. And the last main interesting thing to talk about is that all the graphs showed those 2 main router groups among the trace route. A lot of routers are grouped at the top and a lot of them at the bottom. Our hypothesis is that this big gap occurs where there's a top level server carrying the packet over a very, very long distance, and that before and after that hop is all the local servers. So they're all very similar in time as they're working their way up, and then that big long hop separates them all, showing that big hop in the graph.
In summation of this experiment, UCSC had the most hops, possibly causing it to have the highest ping delay. Oxford had 3 hops, and Virginia Tech had 1 hop that returned 100% packet loss. Virginia Tech had one server in which the ping changed drastically throughout the day, in contrast to every other hop throughout our experiment. And finally, the peak average ping delay across all routers was during 6 to 8 p.m. And besides this, there were no other real trends throughout the experiment.
And thank you very much for listening. That was our presentation for the extra credit projects.